Introduction to fiber optics. Communication. The term communication is defined as the transfer of information from source to destination. For the good communication, efficient communication system is required. The problem is loss of signal during the communication process due to distortion and attenuation. Attenuation is reducing the signal. So in the fiber optics, the light is reducing. This problem was taken up by the engineers in early 1970 with the fabrication of low loss optical fibers and semiconductor lasers, which led us to revolutionary concept of optical fiber communication systems. The application of the fiber optics are now ever increasing with proliferation, it means rapidly increased, of internet along with in the areas of telecommunication, sensor and many more. What is in it? Basically, the communication system has three parts. First is transmitter, second is transmission, and third is receiver. The transmitter will transmit the signal, either diode laser or light emitting diode. The transmission means carrier guide or the channel where the light is passing, or receiver, which is photodetector, detects it and signal is electronically processed to retrieve the signal. If you look at the circuit, like data in goes to buffer, buffer is connected to by metallic, and it goes to optical source modulator. Optical source modulator, it also sends the signal optical source, and this optical source and optical fiber to the fiber optic connector, one fiber optic connector to another fiber optic connector, which is connected to cabled fiber optics, and the, the signal is detected by the photodetector and it is amplified by the amplifier. So this system is transmitter, this is a carrier guide, and here it is a receiver, and it is again metallically connected to threshold detector to buffer, and the signal is or the data out. The transfer of information from one place to other place by the fiber optics. How it is done? So source to source coder to channel coder modulator, then the carrier guide, then demodulate, the channel decoder, source decoder, and destination. So if we need to transmit a signal or information over a longer distance, the information or signal is modulated on electromagnetic waves such as radio wave or microwave. Okay, then it transmitted by the transmitter through a channel. This is channel, and it is received by the receiver at other end. This modulated information then demodulated and converted into a required information. Why laser-based fiber optic systems? With the development of laser, which provides reliable and powerful coherent radiation, and the possibility of use of electromagnetic waves, which having the optical range of frequency. Optical range of frequency. There are mainly two reasons due to which it is natural to use the light for communication purpose. First is higher frequency, and second is more information carrying capacity compared to conventional radio or microwave carriers. However, as light wave cannot travel a longer distance because of high dissipation rate of energy in the open atmosphere. It requires some kind of guiding channel or the carrier guide just in case in the electric current required metallic wire. Similarly, light waves for communication require optical fiber to provide crucial wave guide for light. Thus, the fiber optic is a technology related to transportation of optical energy in a guiding medium, especially glass fibers. This communication system is known as fiber optic communication system. The principle of optical fiber, the total internal reflection. Here you can see the three image. N1 and N2 is the reflective index of different medium. So if the angle of incidence is less than the critical angle of incidence equal the critical angle, and angle of incidence greater than the critical angle. The total internal reflections happen only if the angle of incidence is greater than the critical angle, then only this TIR, total internal reflection, happen, and light ray or the signal is transformed without decay. Otherwise, it will signal will attenuate with time. Construction of optical fiber cable. We can use the principle of total internal reflection to construct an optical fiber. So here you can see the inner one is core, and then it's covered by the cladding is covered by the coating is covered by strengthening fibers, and then finally cable jacket to protect mainly this core, which can guide the light wave up to long distance. However, we have to keep two important conditions in our mind. First is refractive index of the inner medium must be greater than the outer surface. Refractive index of the inner medium means refractive index of core is greater than the refractive index of the outer surface means cladding. And second, the light wave must reach the wall of the optical fiber at an angle of incidence is greater than the critical angle. Otherwise, the gradual loss of energy will take place and light wave will be attenuated. Attenuated means it is decreasing, it is reduced. Another two images also shown here to understand the construction of the fiber optics. As shown in the above figure, the optical fiber consists of an inner cylinder generally made up of dielectric glass. So that core is made up of dielectric glass. The refractive index of mu1 known as a core, and this core surrounded by another cylindrical cell have its refractive index lower than the core known as cladding. So cladding refractive index has to be lower as compared to core, then only total internal reflection will happen. This cladding helps to keep the light wave within the core through the phenomena of the TIR, total internal reflection. In addition to this, to protect the fiber from the external mechanical influences, The cladding is covered with a soft plastic coating, primary coating, which is often followed by another coating, the secondary coating. In that way, the fiber optics are constructed. Here shows the different fiber optics cable. Acceptance angle. Acceptance angle of the fiber is defined as the maximum value of the angle of incidence at the entrance end of the fiber, at which the angle of incidence at the core cladding interface. Core cladding interface is equal to the critical angle of the core medium. Now we know that the ray which will be incident at an angle less than the critical angle theta c at the interface will suffer partial reflection. It will be not total internal reflection happens, but it happens partial reflection if incident at an angle less than the critical angle theta c, and may be leaked out of the fiber, and light ray will decay. However, the ray which will be incident at an angle greater than the critical angle theta c will go to total internal reflection, and thus this theta max for with the TIR takes place is called acceptance angle, and the respective cone is known acceptance cone. Now the equation is sin theta c is equal to n2 upon n1. So you can write the sin theta c, write sin 90 minus theta r. You can write like this, and sin 90 minus theta r is cos theta r, right? And cos theta r you can write 1 minus sin square theta, root 1 minus sin square theta is equal to n2 upon n1. From the Snell's law, sin theta max upon sin theta r is equal to n1 upon n0. So sin theta r is equal to n0 upon n1 sin theta max. This sin theta r value, if you put in this equation, 1 minus n0 square upon n1 square sin square theta max plus to 1 half is equal to n2 upon n1. So 1 minus n0 square sin square theta max upon n1 square is equal to n2 upon n whole square. If we make or if we simplify this equation, so n0 sin square theta max upon n1 square is equal to 1 minus n2 upon n1 square, so is equal to n1 square minus n2 square upon n1 square. So sin square theta max is equal to n1 square minus n2 square upon n0 square. So sin theta max is equal to n1 square minus n2 square raised to 1 half upon n0. The quantity this n0 sin theta max is known as the numerical aperture, and we can obtain the light gathering capacity of the system can be achieved by squaring of the numerical aperture. Squaring of the numerical aperture. So this is for the numerical aperture equation, and from this equation you can also get the acceptance angle theta max sin inverse n1 square minus n2 square raised to 1 half divided by n0. Okay,